The last thing we need to do today is mix the chemicals that we're going to test the cytotoxic effects on our cells. So we're going to do that by serial dilution in low serum media. Okay, and so what I have already planned out, and then I'm going to ask you guys to do some math for too, is my experimental groups. Okay, and these are going to be on, for you to do the math. But I'm basically going to test antibiotics. So our normal antibiotics are 1%, right? But when we dilute into 2% BCS, we not only take the BCS down from 10 to 2%, we take the antibiotics down from 1 to 0.2%. So I'm going to put some 1% antibiotics. I'm going to do some 2% antibiotics, 4%, 8%, and then also 12% antibiotics. Okay, and so then these are just serial dilutions to half the concentration. And then my 12% will just be some extra just for fun. I am going to ignore the 0.2%. So this will actually be like 12.2%, 8.2%, 4.2, 1.2%. For bleach and ethanol, I'm going to do the exact same thing for both of them. I'm going to do 8, 4, 2, 1, and 0.5%, volume to volume. Okay, so I'll just make the 8% first and then just serial dilute down. And then for sugar, so our normal glucose in our DMEM media is actually high glucose. Normal glucose would be 1 gram per liter, which is 1 milligram per milliliter as well. But in our DMEM, it's 4.5 grams per liter or 4.5 milligrams per milliliter. And so what I'm going to do is just take multiples of that 4.5. So our normal control will have 4.5, and then we'll have 9, 13.5, 18, 22.5, and 27 milligrams per milliliter is glucose in there. And so I have these out to make that. I've already measured out the right amount of glucose to make the 27. The 27. And so when you do the math on this, you have to think about, we want 27 milligrams per mil total. This stuff already comes at 4.5 milligrams total, so you need to measure out, okay, now I need 22.5 plus 4.5, which will get me to 27. So I've measured that out already, and my first job is going to be dissolve that. And so I'm going to go ahead and use the 5 mil pipetter. I know it's not going to be perfect, but it's going to be pretty good. I'm going to mix it a little bit. And also, it's just sugar, so I'm going to stick it in the water bath behind me to help it dissolve a little bit faster. Okay, so I'm going to go ahead, while we're waiting for that sugar to dissolve, let's do these. These are pretty easy to do. So really, I'm just going to start with I measured out some 100% ethanol, 100% bleach, and 100% antibiotics. So I have those to use. And so in order to make 8% ethanol from 100%, we're going to make 2 mils of it. You guys should be able to do the math on that. So I'm going to go ahead and do this twice in order to get the correct amount of media, rather than trying to use the serological pipetter to measure out 1840 microliters. I'll just measure out 920 twice in my 8% ethanol. Again, we do want to keep these fairly sterile. The 100% bleach, 100% ethanol, and 100% antibiotics definitely sterile. These things I got from outside the hood, but if anything's growing in there, then coronavirus is the least of our worries. We got to worry about whatever can survive that. So I'm pretty sure nothing is living in there. So now we just need to add 160 microliters of ethanol. I'm just going to make sure it gets mixed really well. Okay, so that's media with 8% ethanol in it. And now, as I said, a serial dilution is very easy from there. So the first thing I'm going to do is just add 1 ml of media to each of those. Okay, so I did that. I'm going to go ahead and do the same thing with the bleach ones as well. I haven't messed up this tip yet. Since it's a new thing, I might as well get a new tip. Just in case. No harm. So this is where I want to do the 4% and down. So I'm just adding a ml here because it's going to be a ml of 0% plus a ml of the previous one to basically half the concentration. Okay, and I'm also going to do the same thing with the last 3 antibiotic ones because they're going to be serial dilutions of the 8% as well. Okay, so what I'm going to do is pretty easy then. I got my 8% ethanol. This mixer's mixed. Take a ml of it, put it in a ml of 0% ethanol media, and now I magically have 4%. Mix it in. Take a ml of that. Put it in 2%. Make sure it's mixed in. Put it in the 1%. Finally, the 0.5% gets 2 full mils. Okay, and we're going to repeat the exact same thing for bleach because it's the exact same calculations. I'm going to do 920 twice of bleach to get, or of the media. To make sure I didn't do it already. And now 160 of the bleach. All right, you can tell it definitely changed the pH as well because this thing turns very purple. That is what bleach does. And now we're going to go ahead and take 1 ml of the 8%.
We'll mix it in the 4%. Okay, and finally the antibiotics. So the 12% antibiotics is going to be a little bit different. Okay, I just need to make 1 ml of this, so it's going to be 880 of media. Plus 120 of the antibiotic solution. Right, that gives 1 ml. Oh, that even turned a little orange, so that gives us a little color as well. That gives us 1 ml of 12% antibiotics. And then for the 8%, we're just going to do the same thing as we did for the 8% of the others, right? 920 twice, and then, because we're not going to serial dilute the 12% one, because it doesn't make an easy divide by 2 thing. And the reason I did 12% is because 0.5% antibiotics, you know, we're already close to that with the 0.2 control, and then 8 to 16 might be a little bit too big of a jump, so I just decided to do 12 instead of 16. And 160 of the pure antibiotics. And now we'll serial dilute. The 8 to the 4, the 4 to the 2, and the 2 to the 1. All right, so we are done with those 3. The last one to do is the sugar, okay? And so we're making more of the sugar because in order to do the math, right, we need at least 1 ml of each. And so we're going to end up, we're going to take, I made 5 mils right now of 27, but we're going to take 4 mils of that to make the 22. And so we need 1 ml left over for that. So again, we just put that in the water bath so the sugar would dissolve a little bit better. I've already got my math done over here, what I need to do. Okay, so to make 22.5, oh, that's right. So yeah, good thing I reminded myself. Right, so number 1, this glucose that I measured out in powder form, it was not sterile. Okay, and so this is not actually sterile inside there. So we need to make it sterile. And there's several ways we could do it. The easiest way is just to use a sterile filter that's on the syringe. And so this is, again, a little bit tricky to get right, but it's really important if you want to sterilize something inside the biological safety cabinet. Right? And so actually, we don't care much about keeping this thing sterile. Okay? Like the inside there is sterile, but we're not going to end up keeping that way. That's not our concern. Our concern is it's got to pass through the sterile filter. And so the outlet of that sterile filter is what we really need to be careful about keeping sterile. And so what I'm going to do is I'm going to go ahead and get this on here like that. Okay, and so again, I'm protecting that output as much as possible. And here's my tube I'm going to leave sterile. And I'm actually just going to try to balance. I'm going to do my best to balance that. Keep that cap sterile as possible. Okay? And we are going to go ahead and sterilize this liquid. We will lose a little bit of liquid in the sterile filter, which is why I made more than 5 mils. If I made exactly 5 mils, that would have been a problem. So I'm just going to go ahead and put the liquid in there. Again, this balancing act is a little bit tricky, but it works. And then we can push through here. Again, the stuff that's in the syringe right now is not sterile. The stuff that we're pushing through this sterile filter that's going into our 15 mil tube is sterile. Okay, and it appears I pushed all the liquid that's going to go through, so we're good there. Put this cap back on. Okay, we no longer need that one. Okay, so what we need now is we need to go ahead and grab, I'm going to go put 1 mil in here. So this is 27 milligrams per mil of glucose in that DMEM. Okay, and now I need to take, from my math, to go from 27 to 22.5, I need to take 4 mils of this, and I need to add 1 mil of this. Which, okay, so this is 4.5, this is 27. If you do 4 times 27 plus 1 times 4.5 divided by 5, you'll get 22.5. Okay? So I'm going to go ahead and use this one to get the 4 out. Okay, looks like I got 4 pretty good. And now I add 1 of my DMEM that has 4.5 milligrams per mil of glucose. I'm going to mix it up pretty good. Okay, so that was the easy one. You do the rest of the math the same way. Okay, so now I want to go from 27 or 22.5 down to 18. And so my calculation was I need 3.75 of this, and I need 1.25 of this. All right, so we're done. I know this was a long day. Here's all our dilutions, and you can actually see the bleached one was purple, and then it just totally bleached out the color for 8%. The 4% still has some color. That's pretty funny. But so these are the chemicals we're going to add. Actually, don't need these antibiotics, ethanol, or bleach anymore. I'm going to stick these in the fridge to save them for when we're ready to add them. So other than that, it's just cleaning up the cell culture area here, which I think you guys know how to do, restocking supplies, which I remind you guys you always have to do to be kind for the next person. But yeah, so next video we will look at adding chemicals and see what happens to our cells with each of these chemicals.